Hello, how are you doing? It's me, Chris Black, special education teacher, student in SEYSL 702, Professor Hacker's class for the fall 2024 public school year. And I'm here to give my final project presentation for the class and for Professor Hacker. All right, so technically it's just take two, because take one was not up to snuff, right, Professor Hacker? All right, but here I'm going to share my screen with you guys. And I'm going to show you what I am doing. And here we go. Let me make it bigger. All right, there we go. Today my final project is going to be about Kahoot tweak. Earlier this week, during week 6, we did a project where we had to go into Scholastic math.com, I believe, and there was a project there that reminded me of Kahoot. So when this last project came up and Professor Hacker said we needed to take an existing lesson or what we've done and update it or tweak it, I decided to tweak that math.com, but turn it into a Kahoot and give it a presentation for the students in my class. As you can see, I've been teaching geometry this semester. And so it's a geometry Kahoot tweak. My students will recognize the difference between transformation and similarity of shapes and figures and perform proofs to support their conjectures. My core standards are HSG-SRT-A1, verify experimentally the properties of dilations given by a center and the scale factor. HSG-SRT.A.2, given two figures, use the definition of similarity in terms of similarity transformation to decide if they are similar. HSG-SRT.B.5, use congruence and similarity criteria for triangles to solve problems and improve relationships in geometric figures. And RI.9-10.4, determine the meaning of words and phrases that they are using in text. My goal is to engage students and use their knowledge of transformation and similarity. I gave you guys a sample of the class schedules that I use and how we break the class period down. It's roughly it's a 45-minute class, and you start with the do now when the kids come in. Normally, it'll be a little preview of the lesson in terms of geometry and congruence and proofs. We can get them, a little refresher on the previous day's lesson. Then do the vocabulary words, definition to decode, watch geometry videos, geometry Kahoot, and then we do an exit ticket, which is basically to sum up what we've done, the lesson that was taught, and the kids' retention of what was taught during that day, during that class. I am going to skip ahead to my my vocabulary words list. I was an English major undergrad. I like words. I believe words and concepts link together, and in math, that's two. And so I've given the kids vocabulary words that relate to geometry and what we're doing with proofs and geometric shapes and proofs. I like words and I like sentences and I like vocabulary words and word banks because using a word in a sentence is the easiest way I can think of to demonstrate mastery of that word and of that concept, even when it comes to applying concepts to math, which we're doing in geometry. So vocabulary words: transformation, rigid transformation, translation, reflection, rotation, symmetry, congruence, similar, and proof. These are all terms that we use every day. And also when it comes to teaching geometry and the whole idea of data-driven instruction that's going on now, but also in general in terms of the Regents exams that come up, technical language and academic language are important, especially when the Regents exams are concerned, because the kids can do the math, they have to show their proof, but then if they're explaining it, if they're asked to explain what they've done, they've got to use the right language. They've got to use the technical language or the academic language for math, which is transformation, rigid transformation, translation, reflection, etc., in order to explain what they've done. Just like add, addition is sum, subtract, they have to use all the technical language or they'll get points marked off of their exams. we'll move ahead now to the videos. I am a specialized education teacher. I teach an ICT class, grades 9 through 12, the geometry class included. And so I believe in differentiation. And for those of you whom do not know or may not be sure, differentiation is basically based on Gardner's principles of multiple intelligences, the fact that people, individual humans, different people learn in different ways. So as a specialized educator in the ICT class, which is integrated co-teaching class, where we have general education and specialized education students in the same classroom, we need differentiation is very important so that the kids who have assessed needs, whether it be cognitive, physical, whatever, they can access the information, decode it, and work with it the same way as their peers and classmates who have not been assessed. And so there's audio visual, but I like audio and visual because some kids learn better through sight, some kids learn better through sound, other kids learn best through touch. I don't have any manipulative with me now to show you, but in terms of triangles, we use the compass, the protractor, rulers. We draw shapes on the papers and we rotate them around for the kids who are tactile, and that helps them, access and learn the content that we're teaching. I've got 4 videos here. I'll play one of them for you guys. We don't have enough time to play them all, but I'll do something just on the transformations. If it works. If it plays.
Your business is here. Wix, get advanced AI capabilities. For more customization, more time, and more growth. Speed up your website copy.
Welcome to Minty Math. This video will explain the 4 transformations.
Like her accent.
To transform a shape means to change its size or position. There are 4 different ways we can transform a shape: translation, rotation, reflection, and enlargement. Let's look at translation. Translation changes the shape's position. The shape can be translated left, right, up, or down. We measure these movements in units. Let's look at an example. We need to describe how shape A translated to shape B. The description must include 2 details: the change in position horizontally and the change vertically. Pick any vertex of the shape and use this to count how many units the shape has moved horizontally and vertically. We can also use vectors to describe translations. Rotation also changes the shape's position. To describe rotation, we must provide 3 details: the angle of rotation, the direction, and finally the center of rotation. You may find tracing paper helps with finding the point that the shape has been rotated around. Reflection changes a shape's position. Reflection of a shape can be described using only 1 detail: the equation of the line of reflection. It can help to think.
I'm going to stop there, interrupt that, because I want to play you guys another video for the similar shapes. But instead of calling, it's called dilation. It's not called enlargement. They don't call it really enlargement. We've been calling it dilation. So you have reflection, translation, dilation, and the fourth one. The next one are similar shapes. I want to play this because this involves the math that's being used to make these changes. So let's make that. Become a doctor. That'd be great.
$0 Grubhub delivery fees apply. Eligible orders only. Terms and additional fees apply. This video, we're looking at similar shapes, which are shapes like these two, that have exactly the same shape, but are just different sizes. You can normally tell that two shapes are similar just by looking at them and seeing if they're the same shape. But to be certain, you'll need to know all of the angles inside of each shape. For example, if we fill in all of these angles, you can see that both shapes have exactly the same angles. And this tells us for certain that these two shapes are similar. Now, when it comes to exams, they'll normally just tell you that the two shapes are similar. And instead, they'll ask you to work out an unknown side on one of the shapes. For example, if we look at this question here, we're told that these two shapes are similar, and we're being asked to find the missing side length x. The key to questions like this is to find the scale factor between the two shapes, which is basically how many times bigger the larger shape is than the smaller shape. To find it, we just compare two equivalent sides, like these two bottom sides.
What he's talking about is dilation. We're dilating the two figures. As you can see, we're making one, either you can dilate it upward, make it large, or you can dilate it down, make it smaller. So we're enlarging or we're reducing the shape. And that's how we know what the scale factor is. The scale factor is the measurement of how much we're actually dilating it by, meaning we're multiplying times 2, times 3, times point, whatever. That's how much bigger or smaller the object will be after it's dilated.
How many times bigger the larger one is than the smaller? So because 6 centimeters is 2 times bigger than 3 centimeters, the scale factor here is 2. And if you didn't know that, you could have just divided the larger length of 6 by the smaller length of 3, and that would give you 2, which tells you that 6 is 2 times bigger than 3. A scale factor of 2 means that every length on our larger shape will be 2 times bigger than the equivalent side on our smaller shape. So if we're looking for x, and we know that its equivalent side on the smaller shape is this 5 centimeter side here, then all we have to do is multiply the 5 centimeters by 2. To find that side x must be 10 centimeters long. Let's have a go at another one. So this time we're told that these two triangles are mathematically similar.
All right. For the sake of brevity, we'll skip over that, and we'll also think, so we can keep to our schedule. I'm going to stop sharing for a second, and I'm going to reshare again. Or can I minimize this without changing? Let's see. Oh, put this down. And can I bring it up? Nope, can't do it. And what do I want to share? I want to share this. I want to share this. Can you guys see this? I hope you can see this. This is the Kahoot app. When I go to the Kahoot tweet, when I mentioned earlier during week 6, I used the app, the scholasticmath.com website. They had a feature. It was like a little game, a math trivia game. But I use Kahoot all the time to do assessments. I like Kahoot because it's a great way to do formative assessments with the kids to see what their knowledge is at the time before we start a project, during the project, and also after the project. And I try to make it competitive, even though Kahoot is fun and it's competitive anyway. I offer little rewards and incentives for the kids who win, to get them to actually give it their best shot. But Kahoot is a website. You can go to Kahoot It. You sign in, it's free. You can get you a free account. If your school has one, you get a paid account with more features. I'm using the free account part right now. And so they have pre-made Kahoots, and you can make your own Kahoot for any subject that you need it for, and do assessments based off the Kahoot that you make with the information you make, provide your own answers and everything. The Kahoot I'm using today is already pre-made, as part of the system, but it's effective because of what we're studying. So what it is we as teachers, or you guys as teachers, we log in. If you haven't done Kahoot before, you go to the Kahoot website, you log in, you search for what you got, and you get this screen here, which is, when you pick it, And you ask if you want to host, you say yes, host live. And you get this screen here. It's loading up. Loading. You can pick the different features. You have classic mode, winter holidays mode, lecture team mode. I just do classic mode because I try to keep it simple. I try to keep all things simple. That's my mantra. And so I hit start. And what happens is you get this screen here, and all the kids go to the Kahoot site. It's called Kahoot It, and they have to plug in the pin in order to play, in order to participate. So right now, the kids would be we're doing a Kahoot. They'd be having there. You can use it. The good thing about it as well is that you don't have to have a laptop. I let the kids use their cell phones or any mobile device that's capable of accessing the internet while we're doing this. Once again, I always try to find ways for the kids to have positive use of their technology devices as opposed to just, TikToks and other things like that. Here, 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 here. Go food. I put the game pin in. I'm just demonstrating for you guys. But normally the kids will be trying to get in. Cool. 73, 5, enter. And I put my nickname. And I put black. Okay, and boom, black shows up. Right? And since it's just me, as you guys can see, I'll hit start. And then we begin to answer the questions. And we can test my own knowledge. I can assess myself. I will be leading the class and reading the questions. Coordinates of the image of 4, 1 when rotated 90 degrees. Begin. And then just for the sake of this, you can pick anyone. So I'll pick blue. And I was correct. I'm on a roll, right? And I keep going. But it basically proceeds like that. There are 7 more questions in here. And so as we go along, you see it keeps score. So I answered that one correct. And since it's just me, this is my number. This is I got 949. If there were other players playing, everybody who got the question right will be ranked in the top. Those who didn't will be ranked lower based off the making mistakes. And it keeps tabs all the way to the end of the game. So that, once again, the top 3 winners, I try to give them some kind of reward or something. But like I said, I like Kahoot, and I think it's a good way to perform assessments and do things for the kids that the kids like to enjoy. And also as educational as well. And so then I will exit out of this though. Because I hope that I gave everybody a good example of how we do this. Like I said, most of you guys have probably used Kahoot before, so you already know how it goes. And this, and we'll stop sharing, and then I'll come back, and then I'll share again. And this time I'll go back to my PowerPoint. All right, and so as you see, we're still on schedule, we're still on track. We've watched the videos, and then we've done the Kahoot, and then we come down to the exit ticket. All right, and bigger. All right, exit ticket is remember that transformation and similarity can be proven using proofs. Homework, write 1 sentence each for each of your vocabulary words. Once again, writing a sentence is the best way to build mastery and demonstrate mastery of vocabulary that I can think of. This is the easiest way, most effective, and kids, depending on how they feel about using words, they get, build their confidence up. But also, once again, it's related to the subject matter, and it's important, and they need to know this, to get as many points, as much credit as they can on the test. For extra credit, we have a scale factor. We saw in the video what scale factor was. So normally all our assignments are posted in Google Classroom, so the kids can go back and access this online and look at the videos again to figure out what the scale factor is. What is scale factor? Write a sentence using scale factor, and to keep them busy. We also try to do extra credit during the class hours just to give the kids something to do, because our administrators They want to use all the instruction time and maximize it as much as possible. I personally believe in free time, but that's just me. And then yeah, and so that's what we do. And like I said, this was inspired. This Kahoot tweak was inspired by a project we did earlier this year during the semester during week 6, and I liked it, and it coincided with my personal feelings about Kahoot and how effective it is and can be, and so I wanted to use it. I hope that it has been educational and entertaining, because I always like to entertain, because I believe education is fun, and I think the kids like it. All right, so I hope this was up to snuff this time, Brother Hacker. I hope you guys enjoyed it, and we'll see what we can see. All right, and that is that. So I'll see you later. Bye.